graphing y equals tan 2x. The general tan equation, function equation, is y equals a tan, open bracket, bx minus c, close bracket, plus d. Well, to sketch this function tan 2x, it's always good to know the parent graph, which is tan x. The parent graph is got a period of pi. That means it repeats every pi. And the line of asymptote is at pi over 2 and minus pi over 2. And it passes through 0. That means tan of 0 is 0. So now the tan of 0, that's 0. Tan of 45, pi over 2 is 90. So tan of pi over 4, which is 45, is 1. And tan of minus 45 is minus 1. So this graph coming from the negative infinity basically goes through 1 like that, and then approaches y in the positive infinity coming from negative infinity. So that's what the graph of pi x looks like. And from there to there, as you can see, from there to there is one period. And the period here is pi. So that's what the tan functions look like, from minus pi over 2 to pi over 2, and it goes through 0. And this is just repeated as you go along. So the next line of asymptote. So the hidden line here is line of asymptote. So tan of 90 and tan of minus 90 doesn't exist. So it's the value is actually 1 over 0. Anything over 0 is infinity if you use a unit circle to draw the graph. So if I also just repeat that for another line of asymptote, because this is pi. So, and I'll be going through pi of, because you need another pi, so that'll be 3 over 2 pi. 3 over 2 is 270, right? Pi is 180 degrees. So this is another line of asymptote there. And as we can see, again, the same thing will happen. Right, so this is, we're going through, so tan of 180 degrees is 0. Tan of 225, this is 225. So that's tan of 225 will be 1. And tan of 135, if this is 90, that's 135 here. It's minus 1. Again, it's coming from negative infinity through to 1, 0 there, and then to 1, and to positive infinity. So that's the way the graph goes. So that's 2 periods now. Period 1, first period, second period. And that's how it repeats every pi. Now we're going to use that idea to just plot this one. Okay, so to sketch tan 2x, we need to think about the asymptote, yes? But before we do that, we need to find the period, because we don't need to worry about the amplitude here in this case for tan, because it goes all the way to, there's no cap, it just goes all the way to positive infinity and negative infinity. So it doesn't have the amplitude in that sense. That amplitude has a different effect. It changes the shape of the tan. It might make it broader or slimmer. But in this case, we have to do period. So let's find the period here. So I'll do period. So period in this case is actually is pi, because it has a period of the pi. So it's going to be pi over b. And b is 2, because that's b. B is 2, so that will be pi over 2. That's period. And we need to do the x scale. So x scale. So the x scale will be, so you're going to have period over, now, x scale, you can see you got two line of asymptote for each period. Two line of asymptote. So that will be over 2, which means is pi over 2 is period, and you're dividing it by 2. Whenever you're dividing by something, you're actually timesing it by 1 over something. So that would be pi over 2 times 1 over 2, which is pi over 4. So the period, the scale is pi over 4. That meant that it goes through, so the line of asymptote is pi over 4, because the line of asymptote here is pi over 2. So we get a ruler and draw pi over line of asymptote here at pi over 4. Pi over 4 is 45. So that's the line of asymptote. Then it will be same as minus pi over 4. So that will be line of asymptote. Because the scale tells us that. It says it's pi over 4, pi over 4. And that's pi over 2. Now, we can plot the graph. But where does it go? Well, this one, when we set it to 0, we get x equal to 0. With set 2x to 0, we get 0 as well. X will still be 0. The start would be, you set the bracket to 0, so that'll be 2x equal to 0, therefore x equal to 0. So that's the start. So that means it starts at x equals to 0 still. So let's just draw a line there, and therefore, but when x, this is pi over 4, which is 45. When x is at 22.5, 22.5 times 2 is 45. Tan of 45 is 1, so at 22.5 is 45. Likewise, minus 22.5 is minus 1. Now if you see, the curve actually goes from infinity all the way to their line and approaches the line of asymptote. So that's the line of asymptote. It's coming from the infinity, never touches the line of asymptote, it just approaches it. So line of asymptote. So it's got there. So this from here to there is a period, and that's pi over 2. Unlike here, a period is pi. So that's what the 2 is doing. It shrinks it squashes the function by half, rather than just, this is a function, that's the parent function, and that's the function that we just plotted. The y range, the range is y colon, in the y colon, that's the y-axis, and that is minus infinity less than y less than infinity. We couldn't say equal infinity because we don't know where infinity is. So we couldn't say equal to infinity. But the domain, interestingly, the domain has a boundary where it cannot cross. This is every pi over 4. You can see pi over 4 there. So the domain, which is x, domain, and that's x colon, it's all real values of x. So real values of x, but it has a limitations, so where x cannot be equal to Well, pi over 4 for a start, because it cannot be equal to pi over 4 or minus pi over 4. So we have to say plus pi over 2n. So that's a domain because it cannot be equal to that. Let's just put n equals to 0. When n is 0, you get pi over 4, right? So yeah, so that cannot be equal to pi over 4. When n is minus 1, you get pi minus pi over 2 plus pi over 4 is minus pi over 4. So it cannot be equal to minus pi over 4. So this is minus pi over 4 because this is 0. So it cannot be equal to minus pi over 4. So that works. And when n is 1, you get pi over 4 plus pi over 2. So we can rearrange that by saying pi over 4, that's pi over 2, which means I could make it 2 pi over 4. Just multiply that by 2, multiply that by 2 to make it same denominator. And that will be equal to 3 pi over 4. And that's 135. So where's 3 pi over 4? Well, this is pi over 4. This is pi over 2. This is 3 pi over 4. You can see that 3 pi over 4 is also the line of asymptote. So that's the line of asymptote. So it cannot touch that line, but it can approach it. So then we can quickly sketch that one. Again, that will be 0 here. So tan of 90, at 90 you do tan 180, and that's 0. So okay, that's 0. At 90, 90 times 2 is 180. And that, so again, it'll be passing through 0, and then minus 1 there, at 1 there, and minus 1 there. So again, it will be coming from the line of negative infinity and all the way. So do not draw your graph with a pen. Always use a pencil in case you want to rub it off. Okay, so that's the way the graph approaches. It's always good to recognize the parent function when you're sketching the actual function.